As the march of AI data centers continues in countries around the world, Chinese companies that make liquid cooling systems are seeing sales heat up. Liquid cooling is an all-around, more efficient way to cool heat-producing computers at AI data centers and is rapidly becoming a preference to air conditioning, which takes up space and uses lots of energy. The production director of a refrigeration company in East China's Hangzhou says the two types of cooling alternatives most in demand are liquid cooling solutions and cold plate components.
In the first quarter, our liquid cooling output exceeded the total production of 6 months of last year, reflecting surging market demand. The strongest demand is for two areas: distributed computing liquid cooling solutions and cold plate components.
Chinese companies that make coolant say their product is just a quarter of the price of imported products, and since data centers are continuously upgrading, Chinese companies that make coolant are planning ahead to meet the expected demand.
AI computing data centers are defined by rapid iteration, with computing power rising 3 to 5-fold each year, which requires us to keep pace with that speed.
According to China Galaxy Securities, the country's liquid cooling market for AI computing centers is expected to reach about $2.9 billion by the end of the year.
A range of key core technologies remain in the hands of a few countries, constraining the development of many others.
Sometime I have met a scientist from HAL. HAL said they are not able to get a continuous source of acrylonitrile good quality, and they did not get the right quality of carbon fiber at import from Japan.
The binocular is very important for the defense, but in our best knowledge, the lens for this binocular is still importing from the Germany. If we could not develop those kind of advanced materials in India, obviously we are losing a lot globally.
How can a country develop a key core technology when starting from nothing? Well, I'm at the heart of China's advanced manufacturing sector, where a material that once confined to aerospace and super luxury cars is now finding its way into everyday life, including my helmets and this bicycle. It's light enough to lift it by one hand, but stronger than steel's. And perhaps most remarkably, it's totally affordable at scale. Known as the king of new material, carbon fiber is rapidly falling in price, and the secret lies in this factory. This March, a Chinese manufacturer announced a mass production of T1200 grade carbon fiber, the strongest and the lightest of its kind on Earth.
像我手里拿的就是我们的 T1200级的这个碳纤维，有手做这么粗的这个纤维就可以拉起80吨重的，相当于一架满载的 C919的大飞机。
Finer than a single human hair, it contains over 90% carbon. This fiber can withstand heat, pressure, and corrosion. From wind turbines to satellites, it is engineered for extremes. China is the first country to achieve mass production of this top-grade carbon fiber. But decades ago, it could not even produce T300, the entry-level high-end grade, at scale, and was cut off by international industry leaders. Around the year 2000, a strategic scientist wrote to the central leadership, elevating breakthroughs in the field to a matter of national will.
材料界的泰斗施参旭施院士说，我们国家还是碳纤维要立足于国内的自主供应，所以那个时候开始拉开了中国企业高度参与碳纤维产业化这样一个过程的一个序幕。
Industrialization and fundamental research move in sync. Thousands of interconnected process points across the production line had to be precisely controlled, each tied to complex reaction inside the fiber. A small change in one setting could affect the fiber's final performance. Scientists cracked them one by one.
在产业化过程中，也是得益于我们原来先做的产业化，然后又倒回来去做技术研究。所以呢，我们从技术研究再到产业化的过程中，我们的这个速度就很快。
Meanwhile, China's rapidly evolving industrial system also pushed the carbon fiber forward. T300 was broken through. From there, higher strength grades followed one after another. Well, the breakthrough is only the beginning. For new material and emerging technologies alike, the question is always the same. Where do they belong? Because beyond what we already know, there is a whole world of uses yet to be discovered. And in the end, they may determine whether these new technologies can survive at all. What role does the state and government play in shaping that future?
像我们那个禅泰大桥里面的那个拉锁，就用碳纤维做的，因为钢材它有强度的瓶颈，大概就2000多兆帕。像我们用碳纤维做，它轻松可以做到3000多。
This is the world's largest scale application of carbon fiber cables. Steel is gradually giving way to carbon fiber in infrastructure.
国家部委就通过项目的牵引，它来承担一部分的这个科研费用，来引导我们把新材料在新的工程里面应用，像碳纤维作为这个拉锁，然后呢再建立国家的这个标准和规范，然后呢这个行业就这样被培育出来了。
China's strong manufacturing capabilities lower costs, and the benefits are global.
去年全年的碳纤维的消费量呢，大概是接近23万吨，其中风电叶片一个应用领域就用了10万吨。我们的很多风电叶片也是出口到欧美，去助推全球的这个能源的绿色化、可持续发展，成本的下降，能够让碳纤维更好的、更有力的服务到更多的应用场景里面去。
Whether we're looking at carbon fiber, whether we're looking at ball bearings, even electric vehicles, it's really about the development and the optimization of an entire system. And again, what I would call the I-5 model, going from an idea that China must have self-sufficiency in strategic technologies to developing the institutions, the instruments, and then building the infrastructure, and then finally seeing the results like T1200.
It was never in an effort of a single company, but in efforts of decades of collaboration between research, industry, and national policy. The mass production of T1200 was not because others slowed down, but because China kept moving forward, fast and with unwavering determination.